All right, here are solutions to, what is this, quiz 2 for Math 251. This first part here is you're asked to find, I guess this is F, is the first thing you know, this weird looking graph. And you're asked to find the limit as x approaches -3 of this function, f of x. So you look over at -3 here, and really the first thing maybe you notice is that this is a two-sided limit. So to evaluate a two-sided limit, what you do is you evaluate two different one-sided limits. And no, you do not need to show all this work. But what you're thinking is, what is the limit as x approaches 3 from the negative side of f of x? And the way you figure that out is you think about if you're just to the left here of -3, what height would you be getting really, really close to? And it looks like that is -1. And then you could do similar analysis from the right-hand side. You could figure out the limit as x approaches -3. So what we're looking at here, -3, from the positive side of f of x. And same idea, except now you're just slightly bigger than -3, but your height is still getting really, really close to -1. And so since these two guys agree, this equals -1. Okay, now you're asked to find the limit as x approaches -1 from the negative side. Maybe I'll switch colors. -1's right here, but from the negative side, I'm down here. I'm slightly less than -1, -1.0001 if you want. I'm standing right there. This guy's height is getting really, really close to 1, so that's equal to 1 right there. What about -1 from the positive side? Well, from the positive side, I'm slightly greater than -1. And my height, when I'm slightly greater than -1, appears to be 2 here. So that answers 2. What about the limit as x approaches 1? Again, this is a two-sided limit, so you look at it from both sides. What am I looking for? 1? I guess I should show my work. Fine. The limit as x approaches 1 from the positive side of f of x, and the limit as x approaches 1 from the negative side of f of x will be the two things that I have to consider if I'm going to figure out this two-sided limit. Well, from the positive side, if I'm slightly bigger than 1, I'm hanging out right here. So my height is getting really close to 0. So this would be 0 right here. From the negative side, I'm slightly less than 1. So I'm standing up here. The height here appears to be at 2. And since these two guys are not the same, we say that this limit does not exist, aka undefined. And just an FYI, you don't need to show all this. I'm just doing it to kind of explain my solutions a little bit. What about the limit as x approaches 4 from the negative side? Well, the limit as x approaches 4 from the negative side. Here's 4. I'm slightly less than 4. I'm down here. Appears my height is getting really close to -1. So that would be that limit there. Okay, now I'm going to evaluate some limits algebraically. So I don't have a graph to deal with anymore. But I can figure these out algebraically. I want the limit as x approaches 2 of f of... Whoa, that doesn't make any sense at all. Okay, there should be no f of x right here. Anyways, the limit as x approaches 2 of this expression. Well, the way I can figure that out is I can't just change all the x's into 2's. I'd get 0 over 0. That's because this is a function is discontinuous at 2. So what I have to do is some factoring. I got to say that this is equal to the limit as x approaches 2 of, and then factor this guy out. Well, it's a difference of squares, so it's x squared plus 4 times x squared minus 4 over x minus 2. And so I still can't cancel out an x minus 2, but I have another difference of squares up here. So I could factor further, say that this is the limit as x approaches 2 of x squared plus 4 times x plus 2 times x minus 2 divided by x minus 2. And now I can cancel out these x minus 2's. Can't just cancel them out, but because I have a limit here, I can say that that limit is equal to this limit. The limit as x approaches 2 of x squared plus 4 times x plus 2. And this as a function is continuous. It's continuous everywhere, but most importantly, it's continuous at 2. And so I can evaluate the limit by taking advantage of continuity. I can just change all the x's into 2's. So I have 2 squared plus 4 times 2 plus 2. Whoops, 2 plus, whoa, what happened there? 2 plus 2, 2 squared plus 4 times 2 plus 2. So 2 squared is 4, 4 plus 4 is 8, and 8 times 4 is 32. So that would be my answer here. How about this next one? Well, again, I can't just change all the x's into 2 into 10 because this is a function, is discontinuous at 10. So my goal is to get rid of this x minus 10 right here. And the way I'm going to do that is I'm going to find a common denominator up here in the numerator. So I'll multiply this side by 10 over 10 and this side by x over x. And that'll give me, how many steps should I show here? Let's do it this way. 10 over 10x minus x over 10x, all divided by x minus 10. And now that I have a common denominator up here, I can kind of mash those two fractions together and get the limit as x approaches 10 of 10 minus x divided by 10x. And that's all over x minus 10, which I prefer to think of as x minus 10 over 1. Because now I got a fraction divided by a fraction, and the way I divide fractions is by multiplying by the reciprocal of the denominator. In other words, this is equal to the limit as x approaches 10 of 10 minus x divided by 10x times 1 over x minus 10. You can almost cancel those guys out. X minus 10, 10 minus x, close enough? No, not quite. But I could make them the same if I factor out a negative 1 somewhere, maybe up here. I could say 10 minus x is the same as the negative of x minus 10. And now I can cancel out these factors and call this the limit as x approaches 10 of negative 1 over 10x. And the great thing about this is it's continuous at x equals 10. So I can evaluate this limit just by changing all the x's into 10. I get negative 1 over 100. And the last problem on the quiz, finish these solutions so I can get back to my basketball game. We're trying to evaluate this limit here. You see a square root. Maybe you immediately think, oh, I got to multiply by the conjugate. I got to multiply the numerator and the denominator by the square root of x plus 7 plus 3. And I got to make sure I do that on the top and the bottom so I don't change the value of this limit. And a nice thing happens when you multiply by the conjugate. All sorts of stuff cancels out. The square root of x plus 7 times the square root of x plus 7 is just x plus 7. Square root of x plus 7 times 3 and the square root of x plus 7 times negative 3 will cancel each other out. So all I have is this negative 3 and this positive 3. When I multiply them, I get negative 9. And then in the denominator, I got x minus 2 times the square root of x plus 7 plus 3. And what's nice up top here is x plus 7 minus 9 is just x minus 2. Should I write that as another step? Fine. The limit as x approaches 2 of x minus 2 divided by x minus 2 times this radical square root of x plus 7 and then plus a 3. And so now I can cancel out these x minus 2's and say that that limit is equal to the limit as x approaches 2 of 1 over the square root of x plus 7. Try that again. 1 over the square root of x plus 7 plus 3. And this as a function is great because it's continuous at x equals 2, so therefore I can evaluate the limit just by changing all the x's into 2's. That would give me 1 over, I don't know, square root of 9 plus 3, which is a sixth. And so that would be my answer for this limit, and that is the last question on this quiz.